This video, we're going to be looking at writing exponential functions when given a table of x's and y's. First, I want to look at a linear function so that when we look at the exponential function, we can see the difference. So with this linear function, we can see the difference in every single one of our x's is 1. And the difference in all of our y's is negative 2.2. So if we were to write this function, it would look like y equals mx plus b, because it's a linear function. Our m would be negative 2.2 over 1, and our b, we see we have the 0.02, which is a y-intercept, so we would have 2. So we would have y equals negative 2.2 x plus 2. So you can see with the linear, things change at a constant rate. Next, let's talk about an exponential function. An exponential function is written as f of x equals c times a raised to the x power. So a is our base, c is our coefficient, and x is our exponent. So let's see what happens when we look at this table. It looks like all of our x's are going up by 1. And then what happens here, between this first one and the second one, we go up by 6. And then we go up by 24. And that continues to change. So we know that it can't be linear. So let's look at the ratios between them. If I have 8 over 2, that's 4. If I have 32 over 8, that's 4. And so on. 128 over 32 is 4, and 512 over 128 is 4. So what this tells me is that my a, my base, is equal to 4, because each of these went up by 4, and this was 1. Next, let's try to figure out what our coefficient is. We can go ahead and plug in, and we'll have f of x equals c times 4 to the x. And we know that we have the 0.02. So if we do c times a to the 0, that gives us 2. We know that anything to the 0 power is equal to 1, so we have c equals 2. So our function comes out to be f of x equals 2 times 4 to the x. And we can check to see that that's true. So if we put x equals 1, we should get 8. So let's do f of 1 equals 2 times 4 to the first power, which is 2 times 4, which is 8. So that is our function. Let's look at a second example. This one is a little bit different, but still going to follow kind of the same thing. So we know f of x equals c times a to the x. Okay. But now, each time we go up in the x direction, we go up by 2. And here, if we do these ratios, 1.25 over 0.3125 is equal to 4. And then we have 5 over 1.25 is equal to 4. 20 over 5 is equal to 4. And 80 over 20 is equal to 4. But when we go up in the x direction each time, now we're going 2. So instead of having a equals 4, we have a squared equals 4. So a squared equals 4, we take the square root and we get a is equal to 2. Normally when you take a square root, you would have a positive and negative 2, but a can only be positive, so it's going to be positive 2. And then similar to what we did in the last problem, we can write it out and we have f of x equals c times 2 to the x, and we'll use a point to solve for our c. So we'll have c times 2 to the 0 equals 5. So we have c equals 5. So we have f of x equals 5 times 2 to the x.